So in this video we are going to look at collinearity. So let's have a look at some diagrams first so that we can sort of develop our knowledge of what collinearity actually is. So here's the first diagram, the second and the third. So you might be looking at these just now thinking, well, they're quite different diagrams from each other, or you might be looking at them thinking, well, there's a few things in common. And I suppose both of those observations are correct. They are different, but there are similarities as well. So if we look at the first diagram on the left hand side, we notice that we've got a line AB and we've got another line BC. Now that is one continuous line, I suppose, but it's not a straight line, it's two straight lines joined together. So looking at AB and BC, we can see that we can observe almost that their gradients are not the same, because AB and BC are not parallel to each other. And we can see that because they're going in different directions. They're sitting at different angles as well. So we might also observe though that B is a common point. So we've got the line AB and the line BC. Now if we look at the middle diagram this time, we can see we've got the lines AB and CD. Now you might notice from this that these are parallel, so therefore their gradients are the same. So that means the gradient of AB and the gradient of CD are equal. But there's no common points, so these are two separate lines and they're not attached to each other. And the diagram on the right hand side, we might notice that that is one continuous line. So even before we get to the fact that it's one continuous line, we might notice that the line AB in the first instance and the line BC, well, they are actually parallel to each other, so they do have the same gradient. And secondly, B is a common point. And we can see that those all lie on the one straight line. And that actually is quite important here, because that is collinearity. So collinearity is when points lie on the same straight line. So points which lie on the same straight line are collinear. So let's look at an example here. So show that the points P, -6, -1, Q, 0, 2 and R, 8, 6 are collinear. So our solution then, so I'm first going to examine the points P and Q. And I'm going to have a look at the gradient there. So just a reminder of the gradient formula, it's y2 minus y1 over x2 minus x1. So we always need to remember that our y coordinates are on the top and our x coordinates are on the bottom of the fraction. So that's the y ordinates on the numerator and the x ordinates on the denominator. So here that gives us 2 minus -1 and 0 minus -6. Now it's very important, now that we're in higher as well, that we label all of our gradients, because for some questions we're going to be finding a lot of gradients. So we need to distinguish between them. So this is the gradient of PQ. Okay, so that's the line joining the points P and Q, and this is the gradient. So on the numerator we're going to have 3, and in the denominator we're going to have 6. We can see that that's a fraction which will simplify and will give us 1/2. Now, if we now look at, bring in the point R as well here, and we'll examine the gradient of the line which joins the points Q and R this time. So again, we need to label our gradient, QR, and our y ordinates are on the numerator, that's the top of the fraction, and our x ordinates are on the denominator. That's the bottom of the fraction. So we've got 6 minus 2 all over 8 minus 0, which gives us 4/8, which again can simplify, and we get a half. Now hopefully at this point you've noticed that both gradients that we've worked out here are a half. So if you remember back to the diagram I showed you earlier, we observed that we needed the same gradient so that the lines were parallel. So what we can say firstly is that since the gradients are equal, the lines are parallel. So that's the first statement there. And the second statement, remember we're trying to prove collinearity. So the second statement, since Q is a common point, so you can see that we've worked out the gradient of a line involving Q here, and the gradient of another line also involving Q. So since Q is a common point, the points PQ and R are collinear. And those are two statements that in the exam, if you were asked to prove collinearity, you would need those statements there in order to gain all of the marks available for that type of question. So if you pause the video just now and take this down as a note so that you've got it to refer back to when you're doing the exercise, and then come back and we'll do example 2. Okay folks, so hopefully you've copied that down for me, and we'll have a look at a second example here. So the points A, 1, -1, B, -1k, and C, 5, 7 are collinear. Find the value of k. So this time we're not trying to prove that something is collinear, we're actually told that these points are collinear. But one of the ordinates, the y ordinate of B, is unknown. That's k. So let's start off our solution by examining the gradient of the line which joins the points A and B. So remember your y ordinates on the numerator, x ordinates on the denominator. So k minus -1 all over -1 minus 1. That gives us k plus 1 all over -2. Now we can't do anything else with that just now, so we're going to leave that at the moment, and we're going to examine the gradient of the line which joins the points B and C. So that will give us 7 minus k all over 5 minus -1, and simplifying that will give us 7 minus k all over 6. Now, we know that these points are collinear, so surely then, if those are collinear, then these gradients have to be equal to each other. Because if they're collinear, if the points are collinear, it means that the lines AB and BC are parallel. So that means their gradients are equal to each other. So the gradient of AB is equal to the gradient of BC. Now, I know the gradient of AB is k plus 1 all over -2, and the gradient of BC is 7 minus k all over 6. So I can make those fractions that I've calculated for the gradients equal to each other. Now rearranging this, I need to multiply throughout by the lowest common multiple of the denominators, which is -12. Now when I multiply the left hand side by -12, I'm going to get 6 bracket k plus 1, and when I multiply the right hand side, I'm going to get -2 multiplied by 7 minus k. Expanding those brackets, I get 6k plus 6 is equal to -14 plus 2k. I can then subtract my 2k from both sides of the equation, and also subtract my 6, which will leave me with 4k equal to -20. And then I can divide throughout by 4 to leave me with k being equal to -5. Now again, at this point it would be good to have this example down as a note in your notes jotter. So if you copy this down just now, if you pause the video just now before the screen goes blank, and then I'll give you your exercise on Teams.